Let's start with the founder effect. For this, we're going to have a big area, and that's going to be like our mainland. Then we have some water, and then we have a little tiny little island out here. So this is the mainland, and this is the island. On the mainland, we're going to have a pretty diverse population of triangles. I'm going to draw in some red ones. Draw in some purples. Some orange. So for the founder effect, the environmental change that we're going to model here is going to be a sandbar that appears at low tide. So the tide goes out, and for whatever reason, because of the way the currents were, there's a sandbar now in the middle of the mainland and the island. This will allow some of our triangles to cross over to the island. So I'm going to say a purple one crosses over, and a red one will come over as well. So I'll draw in my red triangle because now he's over on the island. My purple triangle is now also on the island. However, once the sandbar is gone, you now have these two stuck on the island. They can't come back across because there's no more sandbar for them to travel with. So over time, as long as that sandbar doesn't reappear, you'll have very similar population on that mainland. But on the island, because there was only a red and a purple triangle to start there, when they reproduce, you're only going to have reds and purples. I'm going to put my sandbar back in as a dotted line so you know it was there at some point, but it was not permanent. So my reds and my purples made it across before the sandbar disappeared. After they reproduced for a while on our mainland, we still have three different types. We have the purple, the red, and the orange. But over here on the island, we just have purple and red. So what has happened here with the founder effect, and we call it the founder effect because these two triangles are called like the founders. You can think about the founding fathers or some of the first people to come over here from Europe. These are our founding fathers or mothers and fathers so we can have babies, but our founders of the island, which now becomes overrun by triangles. So the founder effect has an environmental change that causes some organisms to move. That's going to happen before the change is reversed, or before that sandbar gets covered up again. And because only some of them moved, the new location has less genetic variation. So our founder effect is an example of genetic variation decreasing, or a reduced gene pool. And that is a reduced gene pool on the island. This gene pool stays the same. This gene pool is reduced because we lose our ability for the orange triangles. The founder effect is not the only way that the gene pool can be reduced. A second method is called genetic drift. Genetic drift looks at a single population. So the single gene pool I'm going to represent as everybody in this rectangle. So here we're not going to have an island and a mainland, we're just having one population. And I'll draw in some triangles to make it easier on ourselves. I'll just do 2 different colors. So this is maybe a whole valley. We have these triangles spread out. And maybe while the purple triangles are hanging out on one side of the valley and the orange triangles are hanging out on the other side, people come in with bulldozers in order to build a new shopping mall. And we're going to build the new shopping mall on this half. So we're going to bulldoze this half of the valley because we need a shopping mall. These guys aren't going to make it. They got stuck. Just an unlucky event wipes them out. Remember that survival is living and then also reproducing. So we're going to allow those that lived to reproduce. And because of the event that we modeled here, there are no more purples left to reproduce. So in our final population, we just have those orange triangles. So we lost a good proportion of our gene pool.